Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening. Good evening, children.
Good evening, ma'am.
Yeah, good evening. Started writing. How many of you completed, children? Have you all started writing?
Yes, ma'am.
Yes, ma'am.
Okay. All right. Please complete it today and share the pictures. All right.
Yes,
Please
ma'am.
complete all the proofs today and share the pictures. Yeah, yeah. All right. So see the first one. Prove that the angles opposite to two equal sides of a triangle are equal. Okay. Prove that we have been using this theorem in many places. So this is the proof. Prove that the angles opposite to two equal sides of a triangle are equal. So we are given, that's the statement. We have to prove the statement. So we are given, see it, we are given a triangle ABC with AB is equal to AC. See, two sides are equal. We should prove that the angles opposite to them are equal. So we are given that AB is equal to AC. We have to prove that angle B is equal to angle C. So we're given a triangle ABC in which two sides AB and AC are equal. We have to prove that angle B is equal to angle C. That is, the angles opposite to equal sides are equal. Now, since we have only one triangle, see here, triangle, we have one triangle ABC with AB equal to AC, and we have to prove that angle B is equal to angle C. We are going to use the concept of congruency, for which we need two triangles. That is by the construction. So see here, construction, so that we have two triangles, and angle B will be a part of this triangle, angle C will be a part of this triangle. So you can easily show that these two triangles are congruent, and hence angle B is equal to angle C, CPCT. We have to take up the construction because we have only one triangle otherwise. Okay, see, this is what we have. You have to take up the construction so that by the way of the construction, you have two triangles. So when you construct, we have two triangles, and angle B becomes a part of this triangle. Angle C becomes a part of this triangle. So you can show that these two triangles are congruent to each other, and then CPCT angle B is equal to angle C. Okay. So construction can be in two different ways, So this is one proof. See here, what you see here is one proof. There's a different one, but both the result is the same in both. So you can either take up this construction or this construction. I hope you understand. It's not a continuation. It's not a continuation. It's like an alternate proof. You can either take up this construction or this construction. So the one proof is like this. The other proof, there's an alternate proof like this. All right. Fine. So here the construction is draw AD. AD. What is AD? It's the bisector of angle BAC. The bisector of angle BAC. Draw AD. The bisector of angle BAC. Here, what is AD? Draw AD perpendicular to the side BC. So see here, either see the line segment AD is going to come from the vertex A and it's going to land on the side BC. The line segment AD is going to start from the vertex A and land on the side BC. So what are the two things this line segment AD can do? This line segment AD can either bisect this angle or bisect this side. The line segment AD can either bisect this vertical angle A, can either bisect the vertical angle, or it can bisect the side. See, there is one angle and there's one side here. AD, it starts from the vertex of angle A and lands on the side BC. So AD can bisect angle A, bisect the angle A, or it can bisect the side BC. So that is what it is. We take one here. So here it is draw AD, the bisector of angle BAC. Here we say draw AD perpendicular to BC. Perpendicular meaning later you will prove that it bisects BC. So these are the two ways of taking the construction. So let's see the first one, where AD is the bisector of BAC. So that means angle 1 is equal to angle 2. By construction, angle 1 is equal to angle 2. See, I'll tell you one thing. Now through A, you can draw so many lines or line segments. Through A, you can draw so many line segments. You can draw so many line segments through A. So many line segments through A. We are taking that line segment which bisects angle A. That's what it is. Now you may have a question in your mind that how do you know that AD will bisect angle A? The answer to that question is we take that line segment which will bisect angle A. See, through A, you can draw so many line segments like this, like this. You can draw so many line segments like this. Okay, so many line segments. Of all these line segments, there is only one line segment here, AD, that bisects angle A. There cannot be more than one line segment that bisects angle A. There's only one line segment that can bisect angle A. We are taking that line segment. We are choosing that line segment AD, which will bisect angle A. So it's not that we're just taking some line and how do we know that this line segment will bisect A. So we know that there is a line segment that will bisect the vertical angle A. There is definitely a line segment which bisects the vertical angle A. So we take that one. So let AD bisect angle A. So let AD be the bisector of angle BAC. That means angle 1 is equal to angle 2. Angle 1 is equal to angle 2. That is given, meaning that we have through construction. All right, so with this, we can start the proof. So we have two triangles. In the two triangles, so this is one triangle ABD. This is the other triangle ACD or ADC. So see here, AB of this triangle is equal to AC of this triangle. That's given to us. It's given that AB is equal to AC. Then by construction, angle 1 is equal to angle 2. And then AD is equal to AD common side. So SAS rule, the two triangles are congruent. So CPCT, you have this angle equal to this angle. This angle of this triangle is equal to this angle of this triangle, CPCT. Which means angle B is equal to, in the whole triangle, it means angle B is equal to angle C. So we have proved that angle B is equal to angle C. Just a minute, children, I'm coming back, just a minute. Yeah, thank you, children. So now let's see the other one. So here the construction is draw AD perpendicular to BC. Draw AD perpendicular to BC. Okay, so draw AD perpendicular to BC. So what do you have here in the two triangles? AD is equal to AC. Then 90 degrees in both the triangles. In the first triangle, this is 90. In the second triangle, this is 90. And then AD is the common side. So this makes RHS because right angle hypotenuse. Because in this triangle, AB is the hypotenuse. In this triangle, AC is the hypotenuse. So right angle R hypotenuse equal, AB is equal to AC, H, and some other side, AD is equal to AD. So RHS rule, the two triangles are congruent. CPCT, we have this angle ABD equal to ACD, which means angle B is equal to angle C. Is it fine, children?
Yes, ma'am.
Ma'am.
All right. Yeah. Now this is the converse of the earlier theorem. Prove that if two angles of a triangle are equal, then the sides opposite to them are also equal. Prove that if two angles of a triangle are equal, here the angles are given to be equal, then the sides opposite to them are also equal. So here we have to prove that the sides are equal. So what are we given? We are given a triangle ABC in which the base angle B is equal to angle C. We are given that angle B is equal to angle C. We are given a triangle ABC in which angle B is equal to angle C. And we have to prove that AB is equal to AC. That is, the side opposite to angle C is equal to the side opposite to angle B. So B is equal to C given. We have to prove that AB is equal to AC. The sides are equal. All right. So again, the construction, children, draw AD, construction, draw AD, the bisector of angle A. Draw AD, the bisector of angle A. So it's a simple proof. Again, take up the two triangles. Take up the two triangles. So here we know that the angles are equal. We know that angle B is equal to angle C, or we are given that angle B is equal to C. So angle 1 is equal to angle 2, given. Angle 3 is equal to angle 4 by construction. Because construction, draw AD, the bisector of angle A. Draw AD, which is the bisector of angle A. So 3 is equal to 4 by construction. And AD is equal to AD, common side. AD is equal to AD, common side. So what is the rule? It's double AS. Because for angle 1 and angle 3, the included side is AB. For angle 1 and angle 3, the included side is AB. And for angle 2 and angle 4, the included side is AC. But we have written something else. AD is equal to AD, we have written. It's not the included side. It's not ASA, it is AAS. So AAS congruence rule, the two triangles are congruent. CPCT, AB of this triangle is equal to AC of this triangle. Is it fine, children?
Yes, ma'am.
Yeah. You can also do the other one. You can also, I'll include that also. You can also draw AD perpendicular, like here we did an alternate one like this. I'll include that also and send the picture to you. So you can also do that. You can also draw AD. So that means this is not there. This is not there. Okay. Draw AD perpendicular. Draw AD perpendicular to BC. So then what will happen? When you draw AD perpendicular to BC, this angle. So this is 3, this is 4. So we have angle 1 is equal to angle 2. Angle 1 is equal to angle 2 given. Angle 3 is equal to angle 4 by construction. AD is equal to AD, common side. So again, by AAS rule, the two triangles are congruent. CPCT, AB is equal to AC. You can also do that, children. I'll include that and resend this slide to you. So you can also draw AD perpendicular to BC. That means you will not have this information. Perpendicular. So if you call this 3 and 4, angle 1 is equal to angle 2 given. Angle 3 is equal to angle 4 construction. AD is equal to AD common side. So AAS rule, the two triangles are congruent. CPCT will have AB is equal to AC. Okay. This is an important proof, children, meaning I've seen this happening many times in the exams. So if the bisector of the vertical angle of a triangle, if the bisector of the vertical angle of a triangle bisects the base, prove that the triangle is isosceles. That means in a triangle, if supposing we have AD, if AD, if AD has two properties, if AD has two properties, that is AD bisects angle A as well as AD bisects the base BC. That means if the line segment AD bisects angle A, that is if angle 1 is equal to 2, and also bisects the base BC, that is BD is equal to DC, then prove that this can happen only in an isosceles triangle. Only if the triangle is isosceles, we can have a line segment like this. Otherwise, in any other triangle, if the triangle is scalene, if the triangle is scalene, supposing this line, this is ABC, ABC like this, and supposing we have AD and it bisects angle A, we have AD and it bisects angle A, but it will not bisect BC. BD will not be equal to DC. Or if AD bisects BC, if AD bisects BC, that is if BD is equal to DC, then angle 1 will not be equal to angle 2. In a scaling triangle, AD will have only one property. Either AD will be the bisector of angle A, that is 1 is equal to 2. Or AD will bisect the base BC, BD will be equal to DC. Both of it will not happen at the same time. AD will not be both of it. So that's what is given here. If in a triangle, okay, we'll say ABC. If in this triangle ABC, we have this line segment AD. Okay, we have this line segment AD, which is coming from A and landing on the side BC. So if we have this line segment AD such that it bisects the vertical angle A. So that means it makes this one equal to this one, angle 1 equal to angle 2. And also it bisects the base BC. That means BD is equal to DC. If AD has both these properties, then the triangle ABC should be isosceles. Then the triangle ABC should be isosceles. Do we understand the, the information given in the statement, children?
Yes, ma'am.
Yes, ma'am.
All right, children. So that's what it is. So we are given a triangle ABC. We are given a triangle ABC in which AD is the bisector of angle A. AD bisects angle A. That means angle 3 is equal to angle 4. And it meets BC in D. AD, it comes down and it meets BC. It meets BC in D such that BD is also equal to DC. BD is equal to DC. Now we have to prove that AB is equal to AC. That is, the two sides of the triangle are equal, meaning the triangle is isosceles. We'll have to prove that ABC is isosceles. Okay, that means we'll have to prove that AB is equal to AC. So you can write that here. We'll have to prove that triangle ABC is isosceles. That is AB is equal to AC. This is what we'll have to prove. Okay, so now again, if you let me draw this. A, B, C, angle 3, angle 4 equal. And remember AD, this AD, this one, it's only given at bisects. It's only given that it bisects. All right, children. It's not perpendicular. See there, see the question. It's not given to be, it will be perpendicular. That's a different thing, but it's not given to be perpendicular. Okay, it's not given to be perpendicular. It's given that this side is equal to this side. Yeah. Now we might think this information given, children. See here, we have angle 3 is equal to angle 4 and we have BD is equal to DC. What else you have, children? What are the equalities we have? Do we know that AB is equal to AC?
No, ma'am.
No, that's what we have to prove. That's what we have to prove. AB is equal to AC, we have to prove. Now BD is equal to DC, we know. What other equality can we write?
Ma'am, AD is equal to AD, common.
AD. Yeah, AD is equal to AD, we can write. Correct. Now tell me, does this satisfy? Do we have any other information, children? Anything else? Do we know that angle B is equal to angle C?
No, ma'am.
No. If angle B is equal to angle C, directly the triangle is isosceles, then we have nothing to prove. So angle B is not equal, it's not given to be equal to angle C. And do we know that this angle is 90, this angle and this angle? No. It's not given. We can't say, no, see, AD is straight. No, it's slanting, so it's 90 degrees here. No, no, no. It should be given it's 90 degrees. So we have only these three equalities. What congruence rule does this make? Or does it satisfy any congruence criterion?
No, ma'am.
Because when we have two pairs of equal sides, we have only two conditions. Either it should be SSS or it can be SAS, nothing else. So SAS means it should be two sides in the included angle. So these are the two sides, BD and AD here. So this is the included angle. And in this triangle, this one and this one, right? So this is the included angle. See, this is the common side. This is the other side. So this is the included angle. In this triangle, it's about this side, this side. So this is the included angle. But we know that angle 3 is equal to angle 4. So that means with the given information, we are not, see, actually, it's very easy. You can just take up these two triangles. Supposing we don't take up this construction, no, it's very easy. You just have to take up these two triangles, show that they are congruent. Once they are congruent, you will get AB is equal to AC. So they are, so the triangle is isosceles. That's all. See, now this construction is not there. Okay, so it's very easy. So we know that BD is equal to DC. That is when we take up the two triangles. When we take up this triangle and this triangle, angle 3 of the first triangle is equal to angle 4 of the second triangle given. AD of the first triangle is equal to AD of the second triangle, common side. BD of the first triangle is equal to CD of the second triangle given. AD bisects BC. But this makes this doesn't this doesn't cater to or satisfy any congruence criterion. So with this, and we also checked, we don't have any other equalities on the two triangles. So with this information we have, we are not able to show that these two triangles are congruent to each other. We are not able to show that they are congruent to each other. So we need at least one more information so that, you know, those some three equalities cater to a congruence rule and we can show that the two triangles are congruent. So that is why the construction. Because the equalities which we have are not sufficient to show that the triangles are congruent. So that is why we have the construction. So what is the construction? The construction is, so this was actually not there earlier. Now the construction is you must produce AD to a point E. You must produce this line segment AD to a point E such that AD is equal to DE. That means if AD is 5 centimeters, if this AD is 5 centimeters, pull it down to a length of 5 centimeters. If AD is 5 centimeters, pull AD down to a point E such that D is 5 centimeters. That is AD is equal to DE. Produce, so how do you say that? Produce AD to a point E such that AD is equal to DE. So if AD is 5 centimeters, DE also will be 5 centimeters. That's a construction. We see, what do you mean by construction? Construction is something which is possible to do, which you don't have to prove that it is possible. Now, can't we produce, see, now just ask yourself these questions. Can't we, using a scale, can't you produce this line segment AD to a point E such that AD is equal to DE? Can we do it, or should you prove that it's possible? Using a ruler, can we produce AD to a point E such that AD is equal to DE? Is it possible? Okay, you're not, you don't understand that?
Yes, ma'am.
So yes, meaning you don't understand, or is it is possible?
I can't understand, ma'am.
Very good. Okay. Now I'm trying to explain what this construction means. What is this construction? Construction. See, when we say construction, we are doing some, we are including some more information in the diagram, given figure, which is possible to be done, and which, all of us will agree. You don't have to prove that that construction is possible. Why do we do the construction? Because we don't have sufficient information. We're trying to get some more information. So we make use of some construction so that, there is some extra information, and we are able to prove the result. Now, what I'm saying here is using a scale. Now you have this figure already. You have A, B, C. Okay, you have AD, you have AD. Now, so the first thing is take out a scale. That's possible, right? And keep it on AD. Is that possible? Say yes. Yeah. Now, if AD is 5 centimeters, you should mark E below here so that this is also 5 centimeters. Is that possible to mark?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah. Now just produce it and join. So mark a point E such that DE is equal to 5 centimeters, because AD is 5, DE also is 5. And join DE. Is that possible?
Yes, ma'am.
And can you join? Is it possible to join CE like this?
Yes, ma'am.
Yeah. Now, by doing this, we are not disturbing any information in the original figure. By doing this construction, we are not disturbing any information in the original figure. So construction is something which is used, when information is not sufficient, but you'll have to prove some results. So we make use of some construction in order to get more information to prove the desired result. Okay, so here produce AD to a point E such that AD is equal to DE, and then join EC. Join EC. Now the proof. So I told you this is how you should present your answer. Given what is given, what is to be proved. So you can write to prove that also. To prove or to prove that. To prove that. In short, we write TPT also. TPT to prove that. TPT to prove that. Then construction and then proof. Construction, if any. Given, you should write to prove construction if there is any construction, and then the proof. Now, take up these two triangles. Take up these two triangles. Now, let's prove that these two triangles are congruent to each other. Now, see here, angle 1 is equal to angle 2. Vertically opposite angles are equal. BD of this triangle is equal to DC of this triangle, because it's given that BD is equal to DC. See, it's given that BD is equal to DC. DC is a side of this triangle. DC is also a side of this triangle. So angle 1 is equal to angle, see these two triangles. Angle 1 is equal to angle 2, vertically opposite angle equal. BD of this triangle is equal to DC of this triangle. That is given. BD is equal to DC is given. BD is equal to DC is given. And then AD by construction, AD of this triangle is equal to DE of this triangle. Construction. See here, AD is equal to DE, construction. So that makes SAS rule. That makes SAS. See here, this side is equal to this side. So S, then this side AD is equal to DE, another S, and between these two sides is this angle. Between these two sides is this angle. SAS rule, the two triangles are congruent. CPCT, this is very important. Now what to write through CPCT is very important. CPCT, I'll tell you once and again, then it will be clear. So CPCT, we have AB is equal to ECE. See here, once you write the triangle, the congruence here, AB is equal to EC CPCT. Okay, this is CPCT. The reason is CPCT. AB is equal to EC CPCT. And angle 3, see here, from this I've told you how to number it and understand. Now this is 1, 2, 3. This is 1, 2, 3. So angle A is 1. This is say 1. B is 2. And D is 3. This is 3. And the other triangle E is 1. E is 1. C is 2. And yeah, D is 3. This is what is CPCT, children. This angle is equal to this angle CPCT. This angle is equal to this angle CPCT. This angle is equal to this angle CPCT. This angle of this triangle is equal to this angle of this triangle. This angle is equal to this angle. And this angle is equal to this angle. So for that, you can mark like this. If it's difficult for you, you just mark the angles. All this in your rough work, you know. Or you can do it with the pencil and erase it also. So angle A, see here in this triangle ABD, in ABD, I'm marking this as 1, B as 2, and D as 3. And the corresponding angles E is 1, E is 1, C is 2, and D is 3, D is 3. So see, this is CPCT. Angle 1 is equal to angle 1, CPCT. This angle 2 is equal to CPCT. This one is equal to this one. This we already know. This we already know. So that's not CPCT. I'm just telling you how we get the matching angles through CPCT. Like this, we'll have to take. So CPCT, we have angle 3 is equal to angle 5. Angle 3 is equal to angle 5 CPCT. But children, we already know, see here, angle 3 is equal to angle 5 CPCT. Okay, but we know that angle 3 is equal to angle 4. 3 is equal to 5 CPCT. 3 is equal to 4 given. So by comparing these two, we have angle 4 is equal to angle 5. Comparing these two, we have angle 4 is equal to angle 5. Now, if angle 4 is equal to angle 5, see this triangle. In this triangle, what is it called? AEC. If this angle, see, I'm not using this line segment in the middle. See here, don't see this one. Okay. Now, in this full angle, ACE, this full triangle, not angle, this full triangle. Okay, angle 4 is equal to angle 5. Angle 4 is equal to angle 5. That means by isosceles triangle property, the side opposite of this angle, that is this side, is equal to the side opposite of this angle, this side. That means AC is equal to EC. AC is equal to EC. That means AC is equal to EC. AC is equal to EC. But CPCT, we already proved that AB is equal to EC. CPCT, we already proved that AB is equal to EC. That means AC is equal to AB. AC is equal to AB. That means the triangle is isosceles. That means the triangle is isosceles because two sides are equal. Let me tell that again for you. Now, till here you should have understood. This triangle is congruent to this triangle by SAS rule. Till here you must have understood. Now, CPCT, you must write this angle is equal to this angle. That is angle 3 is equal to 5. And also AB is equal to AC. Oh, sorry, EC. AB of this triangle is equal to EC of this triangle. You must write that. Now, repeat what I said, children. AB is equal to what? AB of this triangle is equal to which one of this triangle? AB of this triangle is equal to EC of this triangle.
EC of the second triangle.
Yeah, EC. AB is equal to EC and angle 3 is equal to angle 5. Angle 3 is equal to angle 5. Now we'll use this information. 3 is equal to 5. 3 is equal to 5. But 3 is equal to 4. 3 is equal to 5, but 3 is equal to 4. Given. Comparing these two, you have angle 4 is equal to angle 5. Angle 4 is equal to angle 5. Now we'll use this information. Where are angles 4 and 5? Where are angles 4 and 5? 4 and 5 are in this triangle. This triangle. Take away this one. Don't see this line segment. This triangle. There's 4 here. There is 5 here. Now 4 is equal to 5. Angle 4 is equal to angle 5. So if angle 4 is equal to angle 5, we know that there's a theorem which says when two angles are equal, the sides opposite to them are also equal. That means EC is equal to AC. EC is equal to AC. Now, EC is equal to AC. EC is equal to AC by isosceles triangle property. But we already know that EC is equal to AB, CPCT. EC is equal to AB. We already proved it. CPCT. So from this, we have AC is equal to AB. AC is equal to AB. So that means a triangle is isosceles. That means a triangle is isosceles. Is it fine, children?
Yes, ma'am.
Yes, ma'am.
All right. Okay. So here in an isosceles triangle, prove that the altitude from the vertex bisects the base. The altitude from the vertex bisects the base. Altitude meaning it makes 90 degrees with the base. The altitude from the vertex bisects the base. So we are given an isosceles triangle ABC. We are given an isosceles triangle ABC. We have to prove that the altitude from the vertex. So this is the vertical angle. This is the vertical angle. So default, these two sides are equal. Isosceles triangle. So these two sides are equal. This side is equal to this side. And this is the vertical angle. This is the vertical angle. This is the altitude from the vertical angle. This is the altitude. AD is the altitude. Altitude immediately means these angles are 90 degrees. Altitude means it's perpendicular to the base. You should prove that it's perpendicular to the base, but you should prove that it bisects the base. You must prove that it bisects it. It's a very simple proof, children, but you still need to understand the statement. So you're given an isosceles triangle. This is the vertical angle. This is the vertex or the vertical angle. All these are vertex only. Vertex, vertex. This is the vertical angle. The altitude from the vertical angle. The altitude from the vertical angle bisects the base. Bisects the base. Altitude means it is perpendicular to the base. So angle 1, angle 2 is equal to 90 degrees. You must prove that it bisects the base. That means you should prove that BD is equal to DC. BD is equal to DC. So we are given a triangle ABC with AB is equal to AC. AD is perpendicular to BC is given to you. Prove that BD is equal to DC. The altitude from the vertex, that means it's perpendicular. AD is perpendicular to BC. Bisects the base. Base is a side. Base is not an angle. Base is a side. Bisects the base meaning BD is equal to DC. Altitude is AD. Altitude means it's perpendicular to the base BC. So 90 degrees. So the proof is simple, children. See here, it's 90 in this triangle, 90 in this triangle. Then AB hypotenuse is equal to AC hypotenuse. Because 90 degrees, these two are right triangles, no? So this is the hypotenuse. Hypotenuse. This is a right triangle. This is also a right triangle. So opposite to the right angle, hypotenuse. Opposite to the right angle, hypotenuse. So angle 1 is equal to angle 2, 90 degrees given. Then AB is equal to AC, that's given. And that's the hypotenuse, equal hypotenuse. And then AD is equal to AD, common side. AD is equal to AD, common side. So by RHS rule, the triangles are congruent. CPCT, BD of this triangle is equal to DC of this triangle. All right, children?
Yes, ma'am.
Yes, ma'am.
Very good.
Yes, ma'am.
Very good. Yeah. Now see, there is the converse of the earlier one. If the altitude from one vertex of the triangle bisects the opposite side, prove that the triangle is isosceles. See here, what were the things given? Here it was given that AB is equal to AC, AD is perpendicular to BC. We had to prove that BD is equal to DC. In the next one, we are given that BD is equal to DC. We are given this one also. We'll have to prove this. We'll have to prove this. We'll have to prove that the triangle is isosceles. We'll have to prove that the triangle is isosceles. It's given that the altitude bisects the base. So the altitude meaning 90 degrees bisects the base. So BD is equal to DC. We'll have to prove that the triangle is isosceles. Okay. So the altitude from one vertex. So we have taken the altitude from A. Altitude immediately means is perpendicular to the base. So angle 1 is equal to angle 2. Altitude means it's perpendicular to the base. So AD is the altitude from the vertex A on the AD is the altitude from the vertex A on the side BC. On the side BC. So angle 1 is equal to angle 2, 90 degrees, because it's the altitude. And it's given that it bisects the opposite side. The altitude bisects the opposite side. That means BD is equal to DC is given. The altitude from one vertex bisects the opposite side. So the altitude AD, it bisects this, it's landing on BC, it bisects BC. It's landing on BC, so it bisects BC. That means BD is equal to DC. With this, we'll have to prove that the triangle is isosceles. That means you should prove that AB is equal to AC. If the altitude from one vertex of the triangle, altitude, so 90 degrees, bisects the base, bisects the opposite side, that means BD is equal to DC. BC is a side, so bisects meaning BD is equal to DC. Then prove that the triangle is isosceles. So take up these two triangles. This side is equal to this side. This is 90, this is 90. And this is the common side. AD is the common side. AD is the common side. You must write reasons everywhere, children. Here you must write common side, okay? For every equality, you'll have to write the reason. If you don't write the reason, the teacher will reduce some marks for that. You must write the reason. And when we say given, it is this given. You should have written this given. This given is this given, not given in the statement, not that. When we say given, it's not, we don't mean that it's given in the statement. We mean we have written it here. So to write given as the reason, you should have written given here without writing this. Supposing you didn't write all this, directly you've written proof and you write BD is equal to DC given. You might lose marks because you've not written that at all. Whenever it's a proof, you must write a given to prove and then start the proof. Okay, so very simple. In these two triangles, these two sides equal. Angle 1 is equal to angle 2. AD is a common side. So SAS rule the triangle is congruent. CPCT, AB of this triangle is equal to AC of this triangle. So if AB is equal to AC, it means the triangle ABC is isosceles. Easy, children?
Yes, ma'am. Yes, ma'am.
Very good. So here we have to prove that the medians of an equilateral triangle are equal. See, in an equilateral triangle, the three sides are equal, the three angles are equal, the three altitudes will be equal, the three medians are equal. In an equilateral triangle, the three sides are equal. All the three sides are equal. The three angles are equal. The three altitudes, they are equal. And the three medians, they are also equal. Equal meaning their length will be the same. In fact, in an equilateral triangle, the altitude and the median, they coincide. Altitude and median, they are the same. Altitude only is the median also. Altitude only is the median also. Okay. Prove that the medians of an equilateral triangle are equal. Okay. So what is a median? You can write on this. We'll just define an altitude and median. Altitude is the line segment drawn from the vertex, drawn from the vertex of a triangle perpendicular to the opposite side. Perpendicular to the opposite side. Median is the line segment drawn from the vertex of a triangle to the midpoint of the opposite side. Midpoint of the opposite side. Median is a line segment drawn from the vertex of a triangle to the midpoint of the opposite side. Median will meet this opposite side at the midpoint. Altitude will be perpendicular to the opposite side, 90 degrees.
Completed, ma'am.
Yeah.
Completed, ma'am.
All right.
Completed, ma'am.
1 minute, ma'am.
Yeah. Correction. This one, you remember, children, we have this in NCRT, right?
Yes, ma'am.
We have this in NCRT, except that I should tell you about this figure. This figure. Just remind me, okay, next class before we continue with the Heron's formula. Kindly remind me. I just have to tell you about this figure. The proof you know already. I just have to tell you what this figure and this figure, means. Because it's time now. I'll explain this one. We'll wind up the session with this one today. Kindly remind me about this, that I have to just tell you something about these two figures. Yeah, I need to explain this one in the next class. Yeah, the others are easy, children. These are easy. You can help yourself. Yeah, the others are simple. So this one alone, I thought I can finish it in today's class. So this one, this proof I have to explain. And also this one, I need to just talk about these two figures. These two, please remind me in the next class. So with that, we come to the end of congruent triangles. We'll continue with Heron's formula in the next class. Yes, children. So about this one. So here we have to, we are given that the triangle is equilateral. The triangle is equilateral. We'll have to prove that the medians are equal. Okay, so these are the medians. So see here, what is AD? AD is a line segment from the vertex A to the midpoint of the opposite side. See, because AD is the median, that means D is the midpoint of BC. And BE is the median. B is the median. That means E is the midpoint of AC. Understand, children?
Yes, ma'am.
Yeah, CF is a median. CF is a median. That means F is the midpoint of AB. So these are the midpoints because AD is the median. This is the midpoint because BE is the median. CF is the median. So this is the midpoint. So that means what? AE is equal to EC. BD is equal to DC. AF is equal to FB. What else we know? We know that this full angle is 60 degrees because equilateral. This full angle is 60, this full angle is 60, this full angle is 60. And we also know that all the three sides are equal. We also know that all the three sides are equal. All right. So we have all the three sides equal because it's an equilateral triangle. We have each angle equal to 60 degrees because it's an equilateral triangle. And since AD, BE, and CF are medians, D is the midpoint of BC, E is the midpoint of AC, F is the midpoint of AB. So midpoint, so AF is equal to FB, BD is equal to DC, AE is equal to EC. So we have so much of information. We just have to prove that AD is equal to BE is equal to CF. The three medians are equal. AD is equal to BE is equal to CF. That's what we'll have to prove. Okay, we are given that triangle ABC is equilateral. We are given the triangle ABC is equilateral. Medians are equal. So again, take up two triangles where you can, get maximum information. One triangle should, okay. So to prove that AD is equal to BE is equal to CF, see here what I have proved. I have proved that AD is equal to BE and see here, AD, BE, CF. What I've done, I have proved that you can take different triangle combinations, children. This is not the only way. Please explore with that. This is not it's not a standard thing that you have to take only these two and these two triangles. So I have taken two triangles which have AD and BE. I've taken one triangle which has AD and another triangle which has BE. Okay, and I proved that these two triangles are congruent, so I get AD is equal to BE. And then again, I've taken another triangle which has, or you can rather take the same triangle also with another triangle that has CF. AD is equal to CF. AD is equal to BE. AD is equal to CF. It's like I've proved that A is equal to B. A is equal to C. So A is equal to B is equal to C. So I have proved that AD is equal to BE. AD is equal to BE and AD is equal to CF. AD is equal to CF. AD is equal to BE, AD is equal to CF. So AD, BE and CF, all the three are equal. So what I have done here, I'll just tell you what I have done. Maybe with the help of that, you can think of other ways of doing it. I have taken up the triangle ADC. ADC. You can also take ADB. ADB also has AD in it. You can also take up that. ADC I've taken because it has AD. Correct? Because it has AD. So I've taken ADC. You can also take ADB. ADB also has AD. You can take up that also. Okay, that's the first clarification. Now ADC has AD. So I've taken ADC. Now I have to take another triangle because my first thing is I have to prove that AD is equal to BE. So I have to choose another triangle that has BE. BE. So I have taken the triangle BEC. 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 So you can see the triangles individually here, ADC triangle and BEC triangle. Now see here, children. If you see BEC, you see it here. You see BEC here, children. BEC here. Don't see these things. This is BEC, right? Can you see the whole of angle C? Can you see the whole of angle C in the triangle BEC? Don't see these things. See triangle BEC. You have the whole of angle C. In ADC also you have the whole of angle C. So this angle is whole of angle C, 60 degrees. This one is also whole of angle C, 60 degrees. So angle 1 is equal to angle 2, 60 degrees. Then CD of this triangle is equal to CE of this triangle, because we know that BC, all the sides are equal. BC is equal to AC, all the sides are equal. So half of BC will be equal to half of AC. What is half of BC? Half of BC, DC. And what is half of AC? EC. So CD is equal to EC. CD is equal to EC because the two sides are equal. The two sides are equal. Their halves are also equal. Their halves are also equal. BC is equal to AC. Equilateral triangle. So half of BC will be equal to half of AC. If two things are equal, their halves are also equal. Now what is half of BC? CD. BC, half of BC, CD. You can write BD, but it's not a part of the triangle ADC. So write CD. And what is half of AC? Half of AC. It can be AE or EC. But you write EC because that only is a part of the triangle BEC which you have taken up. That's all. So this one is equal to this one. This is the whole of angle 60 in both the triangles. And you can see here AC is equal to BC. That is the two sides. AC of one triangle is equal to BC of the other triangle because it's an equilateral triangle. All the three sides are equal. So the two triangles are congruent, and CPCT you will get the result AD is equal to BE. And in the second one, I've taken the same triangle ADC with another triangle that has the median CF. I've taken the same triangle ADC with another triangle that has CF, and that CF is in BCF or BFC, BFC or BCF, BFC or BCF, same thing. I've taken the same triangle because see, you'll have to fix your idea first, because I'm proving that AD is equal to BE from these two triangles, and I have to prove that AD is equal to CF. So AD is already in this triangle, so I'm taking the same triangle, and CF is in this triangle. In the same way you will get information, children. CF two sides are equal, their halves are also equal, so you have CD is equal to BF, CD is equal to BF. Then this angle C is completely there in both the triangles. Sorry, not C. This angle 3 and this angle 4. This angle C is completely in this triangle ADC, and in the other triangle you have this angle B completely. Angle B completely. Angle C is equal to angle B because equilateral triangle. All the three angles are equal to 60 degrees. Angle B is completely in this whole of angle B is in the triangle BFC or BCF. And the whole of angle C is in the triangle ADC or ACD. 60 degrees. And you can see that AC is equal to BC because they're the sides of the triangle ABC, which is equilateral. So the two triangles are congruent. CPCT, we have AD is equal to CF. AD is equal to CF. Once you write the order correctly, you will find that AD is easier. DA or AD is equal to FC or CF. So when you compare 1, 2, and 3, sorry, 1 and 2, not 1, 2, and 3. When you compare 1 and 2, or from 1 and 2, we get AD is equal to BE is equal to CF. Is that fine, children?
Yes.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
All right, children. Use the emoji. Raise your hands. The 5 of you. Tanishka, Sindhu, Sanjay. Very good. All right, children. All right, children. So that's it for today's session. Please complete your classwork and share the pictures with me. Yeah. Thank you, children. You may leave the call.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Thank you.